Okay, so I'm going to go through two examples here. So what if I don't give you anything and I just give you a question where it says that theta is an acute angle and cosine theta is 4 over 5. We want to find the value of sine theta. So we know theta is acute. So if theta is acute, we can assume here that theta lies in the first quadrant. Okay, and so since we have cosine theta, it's 4 over 5. Okay, let's just kind of draw the right angle triangle over here. Okay, with this right angle triangle over here, we can safely assume that in ratio, and the ratio length of the adjacent it's 4 units, and the hypotenuse, which is just the length of that line segment, is just 5. And from here we can actually figure out it because we can find the length of the opposite. The opposite is simply equals to the square root of 5 square minus 4 square, and that will give you 3. And so from here we can state what is sine theta's ratio. Sine theta ratio will simply be 3 over 5, and tangent theta will simply be 3 over 4. Pretty simple. Since it's in the first quadrant, everything will be positive, so that's pretty easy. Now moving on to this. So what happens if we have different conditions and we have that tangent theta, cosine theta has this value of 5 over 13 and tangent theta is less than 0. And we want to evaluate sine theta and tangent theta without using the calculator. So in this case, what we're going to do is point out some very important information, which is tangent theta is less than 0. So ASTC, if tangent theta is less than 0, it can exist in two quadrants, right? So we can say that since tangent theta, let me kind of erase this first and maybe use a bigger one. Okay, so since tangent theta is less than 0, it lies in the second or fourth quadrant, right? ASTC. So tangent is always positive in the first and third, so it will be negative in the second and fourth. With that, we have that cosine theta. Okay, since cosine theta is equals to 5 over 13, which is a positive value. Okay, so it lies in, or maybe instead of using it, I'm going to use or, right? Sorry, not or. I should use theta. So theta, theta lies in the first and, sorry, not n, should be or fourth quad. Okay, so we now know that theta lies in the fourth quad. Now with this revelation, I would say, okay, we can kind of depict where theta will lie now. Okay, and it won't be anything fanciful because now it lies in the fourth quad, and we know that theta will be the angle. The angle that we're looking for is from here, make one round over here. So this will be theta. So I think the first step to all these kind of questions is really you need to figure out where the angle lies at first, be it lying in the first or the fourth or the third or second. So now with that information, we can actually kind of look at here and kind of figure out, using Pythagoras theorem again, how we're going to figure out where this angle is. And we can actually, because cosine theta of this angle is here, we can say that the basic angle, okay, will also be equals to this angle, right? So this will be the basic angle, and we can say that the basic angle would be 5 is over the adjacent is 5 and the hypotenuse is 13. So with that, we can safely say that we want to evaluate, we're going to use Pythagoras theorem first to find the opposite. So the opposite will simply be equals to the square root of 13 square minus 5 square, and that will give you 12 if I'm not wrong. Okay, so minus 5 square, yeah, it will be 12. So with the opposite being 12, we can actually now figure out what is sine theta. Now sine theta will just be the basic angle over there, right? The basic angle over here, it's alpha. Okay, so but we know that sine will be negative here, so therefore sine theta is going to be the negative of this 12 is missing. Sine is the negative of sine theta is the negative of 12 over 13, which is just simply the negative of the basic angle. And tangent theta will also be negative because this is in the fourth quadrant, and this will give you 12 over 5. Okay, so that is how you solve such questions given information and finding values of the trigonometry ratios. Thank you.